excited to be talking about AI today because when we look back on this time period historically, this is going to be known as the time of the AI revolution. And I myself have been in this space for about 25 years, I would say. As one of my business partners likes to say, we were doing this back when they referred to it as statistics. And one of the things that really excites me about being part of OneMagnify is we're able to bring together kind of three pieces to deliver customized solutions to all of our clients. And that is data, analytics, and technology. And there's nothing that summarizes those three pieces more than AI. And the thing is, when we talk about AI, it's a term that's thrown around so widely. We have to stop for a minute and think what it is we're really talking about. So AI is a huge area. So when we think about AI, think about it the way that we think of science. Are we talking about a baking soda volcano, or are we talking about space travel? The same thing is true in AI. AI is essentially a system which makes decisions and acts upon them based on data. Now, I would venture to say that everyone in this room grew up with a form of AI in their household, and that's the thermostat. I don't mean a smart thermostat that we adjust on our phone. I mean you crank the dial to 65. Once it hits 63 degrees, furnace turns on, 67, it turns off. And that, in its simplest form, is what AI is doing. It's making decisions based off of data. But more than that, it's trying to replicate human behavior. And so in this instance, what we're replicating is, I'm cold, I'm going to throw another log on the fire. I'm warm, I'm going to open up the flue and let some of the air out. Now, AI takes various forms. And within the automotive sector, there are a few that are really driving things forward. So we have machine learning and robotics. We have computer vision, speech recognition, natural language processing, and generative AI. Now, I group these into three different categories, which I consider to be the different revolutions that have happened within AI. The first of those is machine learning, and this has really changed the way in which vehicles are made. The second is the computer vision space, and this has changed the way in which our vehicles interact with the world around them. And then finally, what we're in the midst of right now is really the generative AI revolution, which changes the way in which consumers act and interact with both our brands and our dealerships. So I'm going to touch on each of these briefly and really focusing in on the process that they're trying to replicate. So if we start with machine learning. So machine learning is mimicking the process of differentiation. So imagine you're at a farm. You have fruits and vegetables in front of you. You need to sort them. You're going to do this based on the attributes of what you're looking at. Is this round? Is this oblong? Is this yellow? Is this green? Does it have a hard skin, a soft skin? Based on these things that we can quantify. So these are attributes which are quantifiable that we can turn into data. We then are able to predict what type of fruit it is. We're able to predict based on knowing which type of fruit it is and the size, how much it would weigh. These are the models that have been around for hundreds of years, ever since Gauss first started doing these things to predict the orbit of different planets. But what has changed with machine learning was probably about 10 years ago now, back in 2014, with the introduction of the extreme gradient boosted models. Because these historic models that we had, that we would build things off of, were based on a data set, and then we would fit it to a distribution, and we would go from there. There are certain assumptions that came into this. We would assume, normal distribution, independence of errors, those types of things. But with machine learning, the approach was, hey, we're going to take a step back and we're going to say more models are better than one models. So first we went through with this and we took a look at the approach, which is kind of the random forest model. We're going to grab a subset of data, subset of our variables, build the best model we can, and we're going to repeat this hundreds and hundreds of times. But in 2014, with the extreme gradient boosted models, they took a little bit of a different approach. They said, okay, we're going to build the first model to fit our data as best as we can. Then we're going to look at how that failed. We're going to look at the errors across those and build that next model. And because of all of the advances we've had in computer science, we can multi-thread these things so we're able to look at more and more data. This has changed almost every aspect of how vehicles are manufactured. Because now we can look at an area, we can say, I know how many vehicles I expect to sell here. Based on that, I also know what I need coming out of my factory. From that, I know when the parts need to arrive. And within the factories, my engineers have looked and they've been able to determine what is the optimal temperature to weld these two pieces of metal together. Also in the design phase, we can see what are the attributes that customers are looking for. So this led to changes in smart manufacturing, this led to changes in robotics, and it's all because with the excess of data that we have at our hands now, we created processes which allow us to utilize that. The second revolution came about was computer vision. Now, computer vision has been around since probably the 1960s, but it has really skyrocketed over the last couple of decades. And so here we're moving from that concept of machine learning into the area of deep learning. And so these deep learning models are mimicking this concept of perceptual mapping. So let's imagine we have a child that can see, speak, and hear. We're trying to teach them language. So we show them an object. We say orange to get them to recognize that this is an orange. As they go through, initially they're going to mess things up. They're going to see a basketball and say orange, and we add more data to the training set essentially for those children to get them to do that. Because now we're going beyond what is quantifiable in the data, like we had with machine learning, where we're saying this is round, it is this color, it is this size. Now we're looking at an object and we're taking the metadata around that to actually create these models. So this goes into these neural networks and these deep learning models that allow us to make connections level upon level so that we can not only identify what images are present, we can identify what images we would expect to be present so that we can determine what is appropriate in a scene, if there are abnormalities, if there are any anomalies in there. And this has led us to everything that we see around the way that our vehicles are interacting with the world now. When we put on that backup camera, we are able to identify not only what's behind us, but whether that's a shadow, whether that's an object, if it's stationary, if it's moving, and then our cars react on that. The same way that when it gets too cold, our thermostat turns on, we have advanced this so much with these models where now our vehicles can stop for us. This has led to the revolution that we have within autonomous vehicles. It also lets us do things where we can tell if the driver is looking at the road or not. So all of these things built on that concept, and it's replicating that concept of perceptual mapping. Now, where it gets interesting, to me, this is all very interesting, but where it gets really interesting is once we go into the generative AI space, because this becomes even more abstract than what we were doing previously. So within generative AI, it is really focusing in on the concept of sensory familiarity. So the best way I have to describe this is I went on a vacation with my family this summer. Across there, we went to a number of grocery stores. I walked into one grocery store and I knew it would have the products that I were looking for because it reminded me of a Whole Foods. It wasn't a Whole Foods, it was an independent chain, but there was something about there that reminded me of it. And this isn't that feeling of deja vu like I've been here before. It's just there's something with the lighting, the smell, the way that everything's set up. That's exactly what these models are attempting to do, is to make those connections. And so these use what's known as a transformer architecture. And so it takes a query that we have, so we ask a question, and then it translates that into a vector, and then it compares that against everything that it was trained against. Now, these models are huge. So if we look at some of the smaller publicly available models, like Llama V2, for instance, the smallest version of that is trained off of 7 billion parameters. So it's able to take that data. So if we ask it a question, if we say, okay, I am planning a trip to Jamaica, give me an itinerary, it will look through everything that it's trained against. And the same way that those sensory cues react for us, we're able to do that with the keywords because it's going to say, okay, based on everything I know, give me everything about Jamaica. But if I'm looking at a trip, it's probably not going to tell me anything about Jamaica Queens because it's going to make the assumption that I'm focused on the country of Jamaica. And what really was revolutionary with this is it solved the problem of space within information. Because when we look at the things that we had with natural language processing, if we were to give it a data set to look through and to churn through and say, okay, the store was closed when I went there on Sunday, or I went to the store on Sunday and it was closed. It will be able to identify that, okay, maybe this is a chain that's not open on Sunday. But for anyone that has ever gone to a recipe online in an attempt to just see what temperature you need to set the oven at, first you have to scroll through this entire blog post about the first time they ever had this dish. And so when you do that, and when they say, okay, on Sunday I did this, I traveled around, I did all of these things, and the store was closed. The models that we had before wouldn't be able to make that connection because they were too far away in space. But these models have been able to accomplish that by solving the issue of these vanishing gradients, kind of being able to identify these further connections. And they do that because they have such an understanding of the way that language works. I like to say they would all make our middle school English teachers proud because it starts off with first this, next that, also this, in conclusion that. That's the way it summarizes things. But the real power that comes from this that we see is in taking this information and then turning it against our own data, because we're sitting on wealths and wealths of data out there that we're not able to utilize in all times. And unlike those first two revolutions that we spoke about, which were really driven by engineers, right? Because when we're looking at the manufacturing process, when we're looking at autonomous vehicles, all of these things are driven by engineering. But within generative AI, it's really led by sales and marketing organizations. Because here we're trying to understand language. We're trying to understand not only what people are asking, but what they mean behind it. And that's where, if we look at the ways in which these sales and marketing organizations are using things, the first thing we always think of when we think of generative AI are the chatbots. That's the thing that's front and center. And these are very good at that. There's no question about that. They have a better, richer understanding of language, of how to answer questions. You can provide them with parameters to make sure that they're not speaking outside of what you want to. But beyond that, there's so many ways that we can use this information in the background to really take advantage of things. Because we're able to look and say, all right, I have a new vehicle or a new feature that I'm releasing. I want to write a press release around that. So generative AI is not going to replace the person doing that. I like to say that generative AI is not going to create an award-winning film. It may very well be able to create a holiday rom-com that's halfway decent, but it's not going to create something truly unique. So we still will have people that are doing that. But now once you create that press release for what you want to say, we can use the models to use what's known as retrieval augmented generation to look across all of the data that we already have. So think of all the social media posts that you've done on different channels. Now these models can understand the voice for each of those channels. It can understand the content that you're trying to portray with the press release that you have, and it can replicate that across all of the different platforms so that you have something that's consistent with your brand, consistent with the information you want, but also tailored to each of those. One area where we've seen a lot of impact for this with different customers that we have is really when they look at these things and how they tie in something like search. Because you're going to have your press release, we're going to tie that into a marketing approach. So we're going to have traditional marketing, we're going to have digital marketing, we have teams that are building out those assets. But then we can also take a look using different techniques to understand what customers are saying. So we can see what conversations they're having with each other, we can see what they're searching for, and then we can build out our websites to speak to those characteristics so that they're easy to find. We're also able to use this to say, okay, when we're doing those things, create email campaigns for me. Touch these different steps so that it builds to a certain cadence and so that we can get there. We're able to use this to understand our consumers and where they are in the process. Because right now, if we think about our approach to marketing as it's been historically, we create a marketing plan, we push it out. And there is some adaptive nature that we'll have across there, usually within CRM, because we know more about those consumers. But now we can look and we can go beyond the Markov models and the Shapley value approach that we've used for attribution in the past. And we can use these models to understand what this customer should see next to push them further in that process. Because we're no longer creating segments of 10 groups where I did not walk into that grocery store and have that relationship with it because I'm a male in my 40s. I walked in there because of the history that I've experienced, because of those sensory cues that were there to relate it to another experience to give me a certain feeling. So now when we think about consumers browsing our websites across all the tiers, not only what they visited, but how long they hovered across things, what they focused on, all of that is essentially creating a level of familiarity with that customer that we can then go to bring out unique content to them. And one of the areas with data that I really love is around call center data. Because we all know data is valuable, right? But call center data is something that we have, we transcribe it, we summarize it. A lot of time it ends up sitting in a data lake somewhere. And we may have our agent that classifies things as positive or negative interactions. But we don't really dig through a lot of that data. But with generative AI, we can take advantage of that by having processes run in the background. So the reason I love call center data so much is because it is really a dance that occurs between the agent and the customer. Because at each time the agent speaks, they have the ability to really shift the direction of that conversation, either in a positive or negative way. And so from that, my team uses a concept that they call emotional progression, where we're not just looking at the overall sentiment, was the customer happy, weren't they happy? We're not just looking at the individual utterances to see if that was a positive or negative interaction. We're looking at it as each point in that conversation turns, so we can identify where the key points are that those things broke down or that those resolutions came about. So myself, I live in Buffalo, New York, so if you know 3 things about Buffalo, it's we have wings, we have the Bills, and we have snow. And so from that, heated steering wheels are something that's important. So this is an example of a customer that was looking for a full-size pickup. They wanted a heating steering wheel within that. They were not able to get an answer from the dealer. They could not get one. So they called the call center. They explained the situation. The call center agent also not able to provide any information. Customer gets increasingly frustrated with this. They're like, I really want this vehicle, but this is something that I need. At that point, the agent says, oh, we do have heated steering wheels in these sedans. Like, might you want to buy one of those? Customer's not happy with this. They're like, look, if you can't understand the difference between a full-size pickup and a sedan, why am I even having this conversation? Now, we can argue about whether or not we want the agent to say that. But the point here is that if we think about how we dealt with call center data, with natural language processing even, so with a form of AI, we would go through, be able to create some connections there, use some algorithms to understand that heating steering wheel is a theme that occurs. And then at that point, people can read through all of the different transcripts we have about it. But with this, we can actually create something that's happening in the background, automatic prompts which are running, which says, take all of these transcripts that happened, summarize them into 5 steps for me. For each of those steps, tell me the main theme, the sub-theme, what the sentiment was for that, what the emotional progression was, and then give me a summary of how the call ended from each person's perspective. Bringing out the data in that way, we're able to see so much more that's happening there and take advantage of all of this data to really create those personalized relationships and understand what's going on with consumers. Oh, twice. And so it wouldn't be appropriate if I talked about this and didn't talk about what I see is coming next. So with these different revolutions that we've had, so we had first the machine learning one. And that was really driven by these extreme gradient boosting models. We had what was going on with computer vision, which we went to deep learning in these neural networks. Then we have that transformer architecture, which allowed us to create these further connections that exist within the data to really understand language. And the next part of this is images. And so the image that you see up here is actually one that I created with generative AI. So this comes from DALL-E. And I asked it for a Van Gogh painting of a statistician solving an equation at a chalkboard. I got a pretty good response from this. But when I asked the same thing for a cyborg doing that, and didn't specify that it was a Van Gogh painting, it looked like something that one of my children would have done in Photoshop where they just pasted something on top of it. And that's because the issue we're running into with these models are that they're trained in different spaces. So this concept of an image is worth 16 by 16 words. Moving away from those neural networks that we've used in the past and being able to use these transformer models with images, we're actually able to take an image, break it into little patches, and then it uses that same methodology where it's using that sensory familiarity to find pieces. And that's what these are using right now. That's what DALL-E's using, that's what Stable Diffusion is using. But the issue is that it's taking two separate models. It's taking our language model to take our query, vectorize that, and then it's taking our images and vectorizing those. But as we know, when we speak in language, it's not the same thing that we see. So what we're doing now and what is underway here is the creation of these cross-modal models. So these are models that use text, language, images, video, audio, all together at once in that encoder and decoder technology of the transformers to create models and create solutions. And so when we look at this kind of going forward, this is the area that is going to change the way that we do things. Because right now we have models which are really good at simulating a conversation. So going back to those chatbots, it's like they can simulate a conversation really well. They can run different processes. But when we think about what these cross-modal models can do, it's more like almost the concept of simulating a dream, because it's bringing together images, thoughts in ways that we don't make that direct connection. It's that same way of walking into the store and just having it feel comfortable. That's the thing that these models are doing, and that's where they're driving to. And so from that, as I stand here today, I cannot tell you the exact ways that these cross-modal models are going to end up impacting our industry, but I can definitely tell you that they are. So thank you so much for your time today.